In today's tutorial we want to solve a problem under which reaction conditions these two substrates, starting materials, an allylic alcohol and this substituted alkyne, will react to give this alene system with a cyclopropane unit. Please try to solve this problem first by yourself before listening to the suggested solutions. So, how can we solve the problem? There are two ways to approach this problem. First one is the retrosynthesis approach. We think about how can we simplify these molecules by cutting bonds. Well, in this case, this is a retrosynthesis arrow. We can say, well, a cyclopropanation we often can achieve by reaction of a carbene and with an olefin, and the olefin would be this allylic alcohol. Indeed, this is one of the two starting materials. And on the other hand, we need such a carbene at an alene system. The second approach from the starting materials is much simpler. We just compare the number of atoms in the starting material to the one in the product. And we will notice that an hydrogen atom and a chloride is missing. So, minus HCl. How can we eliminate HCl? Of course, by applying a base. For instance, potassium t-butoxide. What would happen with potassium t-butoxide adding to a mixture of this alcohol and this alkyne? Of course, the fastest reaction will be the deprotonation of the primary alcohol. It is more acidic compared to a tertiary alcohol like tertiary butanol. However, we also have an acidic proton here at the alkyne. We will also achieve the deprotonation here. At the terminal side of this alkyne, and this of course will remind us of the formation of dichlorocarbene from chloroform, which is easily achieved with potassium hydroxide, potassium chloride is eliminated, and we will get to the dichlorocarbene, which can then undergo the cyclopropanation reaction with an olefin. So here is a very similar situation. Let's say potassium chloride is eliminated, then we would have this alkenyl anion and a tertiary cation at this center. How do we get from here to there? simply by letting this double bond migrate. That's all. And then we notice that these two structures are mesomeric structures. So it's just a stabilization by conjugation. And stabilization is relative in this case. Of course, it is a carbene, and a carbene is always extremely reactive and will undergo the cyclopropanation here. So that's it. I think a rather simple solution. Thanks for listening.